ByteEdge is a platform that uses digital twins with machine learning and AI for predicting product and component failures, providing a virtual connected design, simulation, and optimization capability. The user can leverage this complex knowledge merely on the click of a button via the IotaSmart platform. Customers leverage IotaSmart's AI capability to increase uptime through predictive maintenance, simulate and test with real data, reduce design to manufacturing time, material optimization, cost optimization and energy efficiency, emissions monitoring and analytics. DesignEdge is instrumental in solving the high-volume, low-speed fan conundrum for selecting the optimum number of fans. These fans are used for large indoor spaces to regulate airflow for cooling. DesignEdge's power can be leveraged by the user to speed up this process. One of the key offerings of the platform is DesignEdge. DesignEdge is a design testing module where users can reduce the redesign time of a product by simulating the new design's testing using data generative models. Data generated by these models is customizable based on the need for testing. Let's see how. This software that you're looking at actually suggests the number of HVLS fans and the model of HVLS fans which is required to cool down a place of work according to ASHRAE 55 or the European standards. In this case, the first thing the user would have to enter are the room dimensions. After which, the user would have to enter the operative temperature, the absolute humidity, the metabolic rate and the clothing level. Post this, the software would calculate, according to the ASHRAE 55 standard, the velocity of the air which is required to cool down this space according to the requirement. In this case, the software gets you values of 59 feet per minute and 196 feet per minute. The software would further inform its user about the number of fans needed for a specific model to get the required rate of airflow. Here, the user chooses 2 fan models, PS12 and PS14, each requires about 7 fans. Different types of roofs can also be added. In this case we are taking the M type and then the user would choose the room direction and the span of the roof and then hit next. Taking him to the opening section which is required as openings influence the flow of the air inside the space. Lastly, the user would have to enter the obstructions present inside the space, particularly the different types of obstructions, their dimensions and their locations. Post this, the user can review the keyed information and then generate the 3D CAD model. In the backend, the software automatically generates the 3D CAD model. In a CAD viewer, the user can unselect the roof checkboxes to view the internal layout of the space and also the HVLS fans. The entire space is created without a lot of inputs from the user. Once this is created, the user can send the CAD drawing for flow analysis to the application engineer. The engineer sends the result back in this format. As you saw the application of the HVLS fan, it gives its user a lot of value. It just takes 2 to 4 hours from the time the user inputs the data to getting the airflow pattern in an email without any user intervention. What it does is, it takes the guess out of the decision of the type, the diameter, the number of HVLS fans required to keep the space occupants comfortable. This is a completely customized solution, taking into account the customer-specific design, size, and RPM of the HVLS fan for any sitting or work area. This application can also be extended for ceiling fans and industrial fans.